So this is our last number. So which numbers you will remove? You'll remove P, 2P, and this number. Why? Because their GCD with this number is not 1. So these numbers we will remove. We observe that P, 2P, P raised to K minus 1 into P are the only numbers whose GCD with P raised to K is not 1. Okay. All other numbers, so their GCD is not 1. So we'll remove these numbers. Okay. All other numbers do not have P in its factorization, which do not have P in its factorization as product of primes. Hence, the GCD with P raised to K is 1. All other numbers, they don't have P here. Okay. That means their GCD with P raised to K will be 1. So only these many we are removing. So from P raised to K, we are removing these many. So how many are there? How many are there? 1 minute. Hello. Yes. Which division? Which class? 1 minute. Call me later after 10:40 you go. Okay. Okay. 1 minute. 1 minute. What happened? Did you write the exam? Okay. So we were discussing this. Huh? So we proved this. Okay. Phi of p raised to k is p raised to k minus p raised to k minus 1. Okay. Now, here, bolo. हाँ हाँ प्रूफ इम्पोर्टेंट है ना, मतलब ये तो छोटा प्रूफ है ना, लिख सकते हो ना आप, इतना इतना पहले भी मैंने कराया था, सेम ही है। हाँ मतलब ये रिविजिट अगेन बार बार बता रही हूँ क्योंकि यू शुड बी एबल टू राइट इट डाउन। ओके, so now today we'll learn about this phi of mn. Okay, अगर mn gcd ये m into n, where gcd of m and n is 1. Okay, so if two numbers are there, suppose 45 है, so 45 I can write as 9 into 5, gcd of 9 and 5 is 1, ऐसे रहेगा। तो phi of this is phi of 9 into phi of 5, ऐसे थियरम है। ओके, ये थियरम है, तो थियरम का एप्लीकेशन है, बट टू अंडरस्टैंड द थियरम आई एम यूज दिस नंबर। Okay, first we'll understand using numbers, then we'll go back to the theorem. Okay, proof of the theorem. So now what you do is, so you have two numbers 9 and 5. Okay, so 9 and 5, their GCD is 1. Okay, they have no common factors, so GCD is 1. So now what you do is, you write the numbers 9, अच्छा ये 9 and 4 का किया है। ओके सॉरी, ये 9 and 5 है, ये 9 and 4। ओके, ये जो किया है वो 9 and 4 का किया है। ओके, लेट अस सी 9 and 4 GCD is 1. Okay, so what we do is we write all the numbers 1 2 3 4 5 6 7 8 9 पहले। ओके, फिर बाद में 10 11 12 so on. So this is 2 into 9. Okay, here 2 into 9 comes, here 3 into 9 comes, you write all the numbers, and this is 4 into 9. Okay, 4 into 9 means this is m, this is n. So I am writing the numbers 1 2 3 up to m first. M is 9, and then this is m into n. Okay, n is 4, so m is 9, 9 into 4, 4 is n. Okay, so when I look at these numbers, okay, 1 to 36, when I look at these numbers, what we observe is, if I want GCD of a with mn, okay, to be 1, if I want GCD of any number a here, its GCD with mn, if I want 1, then there is a result that GCD of a with m also should be 1, and GCD of a with n also should be 1. Okay, so any number here whose GCD with this number is 1 has the property that its GCD with 9 will also be 1, and its GCD with 4 will also be 1. Okay, now look at the numbers from 1 to 9. Okay, which are the numbers whose GCD with 9 is 1? Okay, which are the numbers whose GCD with 9 is 1? Okay, from 1 to 9, just observe from 1 to 9. 1 GCD of 1 and 9 is what? GCD of 1 and 9 is 1. GCD of 2 and 9?
1.
1. But so I have tick marked. Okay, this I have tick marked. I have tick marked this. Okay, GCD of 3 and 9 is what?
3.
3. This I have circled. Okay, then GCD of 4 and 9?
1.
1. GCD of 5 and 9?
1.
1. GCD of, so that I have tick marked. Okay, then GCD of 6 and 9. What is GCD of 6 and 9?
3.
3. So that I've circled. Okay, then GCD of 7 and 9?
1.
1. GCD of 8 and 9?
1.
1. So that I've tick marked. Okay, and I've circled this. Now, what I observe is, when I circle this, Now GCD of all these numbers will also be not 1. Okay, that is based on a property. We use Euclidean algorithm. Earlier we had written what is that? See the GCD of see this one. Actually, there is a M missing here. MQ plus R GCD with M. Okay, with M is same as GCD of R with M. Okay, so this is a property. M is missing here, comma M. Okay, comma M, comma M. So M is 9. So what happens? GCD of all these numbers with M is same as GCD of R with M. And so if the GCD is not 1, what will happen? See, look at the circled numbers. Now these GCD is not 1, then all these numbers MQ plus R. Okay, MQ plus R. See, this is M. Next is, this will be M plus 1, M plus 2. This will be M plus 3. So this is some MQ plus R. Okay, so GCD of this number with 9 also will not be 1. Okay, and all these I can eliminate. I will not take all these numbers. Okay, I will not take all these numbers. Okay, whenever GCD was not 1, I will not take all these numbers because their GCD is same as the GCD with this, and GCD is not 1. Okay, so I'll remove all these numbers. Now, all these numbers, okay, all these numbers, GCD with 9 will also be 1. Okay, all these numbers, their GCD with 9 is also 1. Okay, based on that same result. Okay, so GCD of all these numbers is also same as 1. 1 GCD with 9 is 1. So all these numbers GCD with 9 is 1. Just check. See, 10 with 9 GCD is 1. 19 with 9 GCD is 1. 28 with 9 is 1. GCD is 1. Okay. Now I want to use this result. Okay. So GCD of A with Mn will be 1 if and only if GCD of A with M is 1 and GCD of A with N is 1. Now from this column, okay, in this column, I should look at the numbers whose GCD with N. What is N? In here, what is N? This is M. This is N.
4.
N is 4. So the GCD of these numbers with 4 should also be 1. Then only I can combine them. Okay. So here all these numbers GCD with 9 is 1, but I have to look at those numbers whose GCD with what? GCD with N is also
4
1.
is 1.
GCD with N is 1. 4, yeah. GCD with 4. See, look at the numbers. Whose GCD will be 1 with 4? Okay. 10 and 4 GCD is not 1. Okay. 28 and 4 GCD is not 1. So I put it under square. So these numbers, the one which are in the square, what happens? One that is there in the squares, their GCD with what? Their GCD with
4 is 1.
with 4 is 1. So though, and how many of them are there? Okay, how many of them are there? That will come to. Okay, so I got actually 2 here. Okay, so actually it is phi of 4. So each column will have phi of 4 numbers. See, what is phi of 4? Phi of 4 is the number of numbers from 1 to 4 which are relatively prime to 4. Okay, so there is relatively prime to 4, there are 1, 2 is not there, 3 is there. So 1 and 3 is there. Okay, so 2 numbers are there. So there will be phi n numbers. Okay, so there is 1 here, 19 here. This column also will have 2. So which are the 2 numbers whose GCD with 4 is 1? See, this is there. GCD of 2 with 4 is not 1. 11 and 4 GCD is 1. Then this also is not 1. Okay, and so two such numbers means actually phi of 2, so many will be there. Every column will have two such numbers. See, look at the tick marked one here. GCD of 13 and 31 is 1 with 4, but 4 and 22 GCD is not 1. Okay, now look at this. Here also 2 will be there. 14 and 32 will remove, these two are there. Then here this will be 16 and 34 you remove, so 7 and 25 is there. Here 8 and 26 you will remove, the GCD is with 4 is not 1. These two numbers will be there. Okay, so now see how many numbers, those which are in the squares. Okay, those which are there in the squares, those many numbers, their GCD with MN is 1. Their GCD with MN is 1. Okay, now so how you'll count then? So actually the first column, phi of m means what? Phi of 9. Phi of 9 is what? Phi of 9 is 9 minus 3.
3 is equal to 6.
6, that is 6. See, 1 2 3 4 5 6. So there are 6 numbers in the first row. Okay, whose GCD with 9 is what? 1.
1.
There are 6 numbers here, and each column has what? Each column has how many numbers?
2.
2. So 6 into 2. So each row has 6, and each column has 2. That means 6 into 2. Okay, 6 into 2 numbers will be relatively prime to Mn. 6 into 2, that is 12 numbers. You can count the squares. How many numbers are there?
12.
12.
12.
So this is the proof of the theorem. Only thing, one part is there, how this phi of 2n is there. Okay, phi of 4. So how phi of 4 is there, that you have not understood. Okay, so that is based on a little more theoretical part. So actually each column of this, these are same as, later on you will learn, we are learning congruences. Okay, later on. So what happens, each of these numbers are actually congruent to 1 2 3 4. Okay, modulo 4. So each of these two numbers, these numbers here, okay, so they represent actually the numbers 1 2 3 4. Okay, that much you understand now. So all these columns represents what? 1 2 3 4. Okay, all these columns which we have tick marked here, so they represent 1 2 3 4. That means what? So many numbers. Out of this, phi of n numbers will be relatively prime to n. And so when I combine these two, I get phi m into phi n. Okay, phi m into phi n numbers that are relatively prime to mn. Okay, so phi of mn is the number of integers from 1 to mn that are relatively prime to mn. This is explaining this. Okay, and then what we observe here, m is 9, n is this. So there are 6 elements which are relatively prime to 9. And actually here I said I missed out comma m. Okay, so mq plus r is nq plus r. That is there its GCD with 9. Okay, 9, m is 9 is same as GCD of r with 9. Okay, r with m. So for 1 2 4 5 7 8, their GCD is 1. So all the numbers mq plus r in the r column also have GCD 1 with 9. Each column has n elements, that is 4 elements, and each column has phi n, which is phi of 4, which is 2 elements that are relatively prime to 4. Thus there exists phi m into phi n. Okay, so 6 into 2, 12 numbers that are relatively prime to m and n, and hence to mn. Okay, So phi of mn is phi of m into phi of n, where GCD of m and n is 1. Okay, you somewhat followed it. Now I'll explain again. We'll do again. Okay.
मैम
हाँ बोलो.
मैम ऊपर आपने फाई ऑफ ए कॉमा एम एन दिया था, तो व्हाट इज ए?
A is any integer between what? Between 1 to mn. ठीक है. A हम अल्फाबेट किसी कोई भी नंबर्स को दे रहे हैं ना. यहाँ कोई भी नंबर लो आप. यहाँ 1 to mn से कोई भी नंबर लो. अगर आप यहाँ ओके यहाँ कोई भी नंबर रहेगा उसको नाम A दे रहे, जनरल नाम ले रहे. ओके. सो व्हेन विल GCD ऑफ A विथ mn? अभी कोई भी नंबर लो. सपोज 9 into 4 36 है ना. आप कौन सा नंबर लोगे? कोई भी एक नंबर लो. 1 to 36. 1 to 36 का कोई भी नंबर लो. Which number you will take?
मैम 25.
25. अभी 25 is A. A is 25. Okay. Now 25 GCD with 36. 1 होगा क्या? नहीं. So
यस
30.
मैम.
हाँ जब कभी होगा 25 का GCD 36 से 1 कभी होगा? Then GCD of 25 with 9 is also 1 and 25 with 4 is also 1. ये रिजल्ट है. ये एक important result है. Okay. So GCD of A with mn is 1 if and only if GCD of A with m is 1 and GCD of A with n is also 1. This is the result. Okay, which we had done earlier. The proof, just go through the proof. Okay, इसका proof. तो आपको समझ जाएगा. तो have you understood? See, now you take some other A. अभी A आप चलोगे. अभी दूसरा A लो. जिसका GCD 1 नहीं है, ऐसे कुछ नंबर.
22.
हाँ 22 बोल रहे हैं ना. 822. अभी 22 का GCD 36 के साथ, ये 36 है. 9 into 4. ओके 36 के साथ 1 नहीं है. Why? Because see these are also not 1. 22 का 9 के साथ क्या है? 1 है. बट 22 का 4 के साथ क्या है? 1 नहीं है. ओके.
2 है.
हाँ तो when you will get 1 and दोनों 1 रहना चाहिए, फिर ही आपको GCD 1 मिलेगा. ओके. सो दिस इज एन इम्पोर्टेंट रिजल्ट. GCD जब भी किया था, अगर मैंने बोला आपको होमवर्क कुछ तो देख लो, उसका प्रूफ देख लेना. ओके.
यस मैम, अंडरस्टूड.
हाँ अंडरस्टूड ना. ओके we'll do one more sum and then we'll see the general proof. ओके. जनरल प्रूफ में देखो ऐसे नंबर्स नहीं ले सकते ना, आपको जनरल प्रूफ लिखना पड़ेगा. ओके. तो पहले नंबर्स से अंडरस्टैंड करेंगे और फिर बाद में जनरल प्रूफ. एक्चुअली जनरल प्रूफ वो पहले वाले नोट्स जो मैंने लास्ट टाइम सेंड किया उसमें है. So we'll go back to that. Okay. So this is we are understanding it. Okay. अभी M8 है. Okay. N3 है. Okay. तो आप क्या अभी मतलब ये 24. Okay. 24 is 8 into 3. So what I do is I write the numbers 1, 2, 3 up to 8. Okay. I write the numbers from 1, 2, 3 up to 8. Then what you do? You write after 8. After 8, you will write 9, 10, 11, 12, 13, 14. यहाँ क्या आएगा? 2 into 8. यहाँ 2 into 8 आएगा 16. फिर बाद में वापस आप लिखोगे 16 plus 1, यहाँ 17. Okay, next number. So actually this is M. So now I'm making you understand the proof of the theorem. Okay. So now this is 8. M is 8. Next you will write M plus 1. Okay. Then see this is M. Okay, this is M plus 1. वैसे हमको मिलता है MQ plus R. Okay, this is M plus 1. Then this is 2M. See, what will be the next number here? 2M plus 1. ठीक है, ये 2M है, ये 2M plus 1 है. So ऐसे प्रूफ लिखेंगे बाद में. ओके. ये तो नंबर्स है, आपको जनरल करना पड़ेगा. कोई भी नंबर M and N के लिए ट्रू है. तो अगर यहाँ क्या करोगे, पहले नंबर्स लिखोगे M तक, तो यहाँ नेक्स्ट नंबर क्या है? m plus 1, तो यहाँ क्या नंबर मिलेगा 2m मिलेगा. यहाँ नेक्स्ट नंबर क्या है 2m plus 1. कहां तक जाओगे आप ऐड करते जाओगे आपको 3m मिलेगा. दिस विल बी द लास्ट नंबर. m है ये n है, n is 3 into m. Okay, now what you do is you will look at the numbers here whose GCD with 8 is 1. Okay, how many such numbers will be there in the first row? How many such numbers will be there?
4.
There will exist 5m. मतलब 5 of m मतलब 5 of 2 cube. मतलब 5 of 2 cube minus 2. So means 8 minus 4. That is, there are 4 numbers, okay, that are relatively prime to 8 in the first row. Which are the 4 numbers? We'll just see. ये जो 1 है टिक मार्क किया है, फिर 3, 2 नहीं है, 2 नहीं है, 3 है, 4 नहीं है, 5 है, 6 नहीं है, 7 है, 8 भी नहीं है. तो यहाँ 1, 2, 3, 4 4 numbers है whose GCD with 8 is 1. Okay, now all these numbers also GCD with which number is 1? जो भी ये कॉलम में आएगा ना, मतलब MQ plus R, जो भी ये कॉलम में आएगा इसका GCD with M. Okay, GCD of all these numbers with what? All these numbers with
N.
M will also be 1. Follow till here?
Yes, ma'am.
हाँ, तो सबका GCD
Yes.
देखो, ये सभी नंबर्स का GCD विथ M. M क्या है 8, 1 होगा. देखो इस सब नंबर्स का 8 के साथ 1 है, इस सब नंबर्स का 8 के साथ 1 है. मगर आपको क्या चाहिए? What do you require? You require that from these numbers, which are the numbers which are relatively prime to 3 also. Okay, ये जो कॉलम है, हर कॉलम में there will exist 5 of 3. 5 of 3 क्या है? 5 of 3 क्या है?
2.
2. तो हर कॉलम में 2 नंबर्स रहेंगे which are relatively prime to 3. Only this part is little from congruences. Okay, so actually what happens, see 3 numbers है ना, ये 3 numbers है, that will be relatively prime, that will be same as 1, 2, 3. Okay, जो भी number है, तो इसमें 1, 2, 3 जब भी लेंगे तो 5 of 3, that means 2 elements that are relatively prime to 3. So each of these will have 5 of 3, means 5 of 2. तो अभी यहाँ ये लिया है, see ये 1 and 17 relatively prime to क्या है? 3 है. अभी इसमें देखो 3 नहीं है, 11 and 19 है. Okay, they are relatively prime to which number?
3.
3.
3.
Now look at this. ये कॉलम में कौन सा आएगा? पूरा स्क्वायर्स मैंने मार्क नहीं किया है, तो अभी यहाँ आप स्क्वायर बनाओगे तो कहाँ बनाओगे? 5, 30. हाँ 30, 21 नहीं आएगा. फिर यहाँ क्या होगा? यहाँ क्या रहेगा? 6 नहीं लोगे, सॉरी दिस वन जो टिक मार्क किया हुआ है, जो टिक मार्क किया हुआ है. 7 लोगे, 23 लोगे, 15 नहीं. Okay, so now total how many will be there? Total how many will be there? 5 of 8 into 5 of 3. 5 of 8 into 5 of 3. So okay, the यहाँ मार्क किया है, बॉक्सेस बना दिया है. Okay, so 1. So now I'm what are in the boxes I'm writing here? 1, 5, 7, 11. These are all relatively prime to 24. So there is 5 of 8 into 5 of 3. That is 5 of 8 is 4. 5 of 3 is 2. Okay, and so you are getting 8 such numbers which are relatively prime to this. Okay, so here following lemma is used for the above work. What is that lemma? So actually I have used this. Means जो column में 5n numbers क्यों है? Okay, then the integers see यहाँ zero 0 into m. Okay, 0 into m plus r, 1 into m plus r, 2 into m plus r. ये जो जब भी congruence पढ़ोगे ना, that is the next topic actually. So these are congruent modulo n. Okay, modulo n to 0, 1, 2 up to n minus 1. This can be proved. Okay, this
Good
can
morning,
be
ma'am.
pardon. See, this congruence we are doing later on, but actually phi n पहले किया है, तो हर कॉलम में phi n नंबर्स रहेगा जिसका जीसीडी विथ हाँ बोलो हाँ वो लास्ट टाइम किया था ना phi of prime number 3 phi of 3 क्या है phi of
Prime number will be
हाँ
minus of the
p
previous
minus
number.
1 ना phi of p क्या है p minus हाँ ओके
चाय पियोगे? पापे खाओगे?
okay understood this
Yes, ma'am.
okay so now we'll see the proof okay हाँ बोलो yeah I just somebody had whose mic was on I was just looking at okay who is this one
मैम निशा
निशा
निशा सेंड मैम आईडी पासवर्ड निशा ने किसी को सेंड किया है तो अपने दोस्त को ज्वाइन करने को
यस मैम
मैम निशा ने सेंड किया
क्योंकि
है
भाई हम तुम्हारे बाप है ना, इसीलिए हमें सब मालूम रहता है।
1 minute
चाय पियोगे? पापे खाओगे? सुबह सुबह
मैम इट वाज अ प्रैंक, कोई प्रैंक कर रहा
2
है।
मेगापिक्सल का कैमरा
मैम
ऑन
निशा ने
करके
सेंड
ऐसे
किया है
वीडियो
मैम सस्पेंड निशा
पूरा यूट्यूब संस्थान बना दूंगा।
अच्छा
अरे ओ कैरी मिनाटी क्या बोल रहा था? बवंडर कब आएगा?
मैम सस्पेंड निशा प्लीज मैम माय रिक्वेस्ट सस्पेंड निशा गिव हिम 0 मार्क्स निशा क्यों क्या आपने ऐसा अरे माँ की चूत गाली दी रहे
भाई मैं तो बोल रहा हूँ कि दम भर गाली बको इस मीटिंग में। इस मीटिंग में लौड़ा मैं हमें इनको भाई जो झाटा कुछ नहीं आता, ठीक है। इनको तो झाटा कुछ नहीं आता।
अरे भाई
कोमल जैन कैमरा ऑन करो। रहमान ने चोट दिया, कैमरा ऑन करो।
मम्मी बोले मत कर
मम्मी बोले मत कर
पापा बोले मत
आंटी
कर
बोले मत कर
So we'll continue. So here, so all this. So from Tuesday we are going starting offline, na? Happy, na? Offline lectures. Okay, all of you are mute also, I think, na? Okay, so none of those who are there in the classroom will misbehave. Okay, and nobody can join anything now. So see that you be disciplined. Okay, otherwise action will be taken against you. Is it clear? Rukshay Tiwari, who is that one? Why your roll number is not there? Who is Rukshay Tiwari? Roll number, what is your roll number? Rukshay Tiwari. What's your roll number?
Ma'am, my roll number is A109. And it is not Ruk. Ma'am, it is Rushikesh, not Ruk.
Rushikesh. Okay, I didn't. See, you should join with your roll number.
Sorry, ma'am. From next time, I will take.
You can do now also, I think. Okay.
Actually, ma'am, I'm from mobile, so I don't think it will be feasible right now.
Okay. Okay. So 5 of 24 is 5 of 8 into 5 of 3. Okay, this we say. So like I said, we'll do the theorem. Okay, proof of the theorem.
Ma'am, now is 9:52, ma'am.
Pardon? 9:52 क्या? Roll number?
No, ma'am. 10 o'clock को lecture है दूसरा.
किसको है lecture? D division
मैम
को?
कोई मैम नहीं लेक्चर नहीं है ये आयुष हमेशा ऐसे ही करता है रोल नंबर 56 आयुष ये एनी टाइम मैम हर क्लास के एंड पे ऐसे ही बोलेगा कि नेक्स्ट क्लास लेक्चर है प्लीज
मेरा ही
कैरी ऑन
लेक्चर है ना
राइट
हाँ ओके मस्ती कर रहे हो अभी देखो ऑफलाइन चालू हो रहा है अभी आप यू वोंट गेट अ चांस
मैम ऑफलाइन चालू हो रहा है मैम इन लोग की गांड मार दे
don't use unnecessary language okay speak only what is necessary
Sayyid Firdaus ma'am he was using
1 minute unnecessary you should not talk only when I'm asking you some question you have to answer is it clear we want to look into proof of this okay so the proof of this theorem okay like it's explained here also again okay 5 of 5 into 3 so what do you do 1 2 3 4 5 you write then 6 7 8 9 10 then 11 12 up to 50 now from this okay how many numbers are relatively prime to 5 what are the numbers which are relatively prime to 5 1 2 3 4 okay, all 4 numbers are relatively prime and if in this column okay how many will be relatively prime to 3 how many will be relatively prime to 3 that will be 2 5 of 3 that is 2 okay so 5 of 3 is 2 so 1 and 6 1 and 11 6 is not relatively prime. So there are actually, so 4 into, see what is phi of 5? Phi of 5 is what? 4. Okay. Phi of 5 is 4. So 4 into each column has how many numbers? 2 numbers. So 4 into 2. 4 into 2 is
Excuse
8.
me, ma'am. Can you please allow Namrata Sutar to unmute because she's texting me in the phone, like she wants to unmute.
No. See, they
Namrata
can't.
Sutar.
Who is there? Okay, you leave it. They can do. Okay.
Okay, it's fine, ma'am. Yeah, thanks.
Yeah. Okay, so here, 5 into 4 into. So 4 into each column has 2. So 4 into 2, 8. Okay, 8 such elements will be there. Same way, phi of 3 into 4. Okay, so what do you do? 1, 2, 3, 4, you write, then up to like this. Okay, and then what do you do? What do you observe? Phi of 4. Phi of 4 is 2. There are 2 elements that are relatively prime. And each of these will have, again, 2 elements that are relatively prime to 3. And so you get phi of 4 is 2. 2 into 2. 4 elements you will get. Okay. So which are the 4 elements? 1 is there. 5. 3 is not there. 7 and 11. Okay. Somewhat you have understood, no? So here, see, with numbers, now the general proof. Okay. So if the general proof, what is the general statement? What is the general statement? Phi of mn is phi of m into phi of n whenever GCD of m and n is 1. So this is a very strong result again. Why? Because this is a strong result. Why? Any 2 numbers you take. See, अगर आप यहाँ 100 लोगे और यहाँ कौन सा नंबर लोगे? 101.
25.
हाँ, 25 लोगे तो
Sorry,
GCD 1
25.
नहीं है. हाँ, GCD
29.
29 लोगे तो 100 into 29. Okay, so 100 into 29 means 2900. 2900 का phi of that will be what? 29 is prime, na?
Yes, ma'am, it is fine.
Yeah, it's prime. So you'll get phi of 29 into phi of 100. Okay, because GCD of 29 with 100 is 1. Okay, phi of 29 कितना होगा? Phi of 29 कितना होगा?
Ma'am, 29.
29.
Phi नहीं, phi of P where P is prime is P minus 1. 28 आएगा. Phi of 29 will be 28. And then phi of 100. Phi of 100 क्या होगा?
Phi of 100, 39.
Phi of 100 वापस आपको कैलकुलेट करना पड़ेगा.
90. 10x square minus 10.
Phi of 100 कैसे कन्वर्ट करने का? We'll come to that. Okay. So we are learning.
99 होगा.
99 नहीं होगा.
90.
होगा मैम.
100 prime नहीं है ना? 100 prime नहीं है. Okay. Then what you do is mute yourself when you are. We can hear other sounds also. Mute yourself. Mute yourself, students. Okay.
Ma'am,
Now
ये
here,
दो नहीं खत्म होता.
what happened? So phi of mn is phi of m into phi of n whenever GCD of m and n is 1. Okay. So we are going to prove this. So first, see, in the proof, what we are doing, m and n are integers. So phi of 1 is 1, we know. Phi of mn, if m is 1 or n is 1, then I will get
Ma'am,
this.
actually, the thing is that ki Sneha Sharma is sharing the link, the class link to many of the peoples.
See, now nobody can enter the room. Okay.
You have locked it.
You don't worry. Okay. Nobody can enter the room now.
You have locked it, right?
Yeah.
Okay.
Okay.
Thank you.
Let them do anything. Last lecture है ना, अभी कुछ नहीं कर सकते. ठीक है?
Okay, madam.
हाँ. Okay then. So here we are going to prove this. Okay. So phi of 1 is 1 we know, and if m or n is 1, the result holds. Okay, if m or n is 1, the image result holds trivially, we say. Okay, now let m and n be greater than 1. Okay, we are not taking m1 or n1, so they are greater than 1. So now arrange the numbers 1 to mn in m columns. So m columns and n rows. Okay, so 1, 2, 3, ये R है, and going up to m. And then you write here m plus 1, m plus 2 up to 2m. Then 2m plus 1, 2m plus 2 up to 3m. So on up to n into m. Okay. So this is how our numbers are arranged. Okay. What we observe is that we know that again here GCD of qm plus r and m, comma m we have to write. Okay. GCD of qm plus r with m is GCD of r with qm plus r and m. GCD, okay, is same as GCD of r with m. So whenever r is there, what happens? Whenever r is there, GCD of all these numbers will also be same as the GCD of r with m. Okay, GCD of qm plus r, you have to make a correction here, qm plus r comma m. Okay, with m is same as GCD of r with m. Understood? So that is what is helping us. Okay, so all these numbers have same GCD.
Nothing will help you, only God will help you.
Who was that? Yes?
Gibran Khan, ma'am, Gibran Khan.
Okay, so I think now you cannot speak. Okay, so you better hear only now. Okay, so what happens here? GCD of this is 1. GCD of all these numbers will be 1 if GCD of r with m is also 1. Okay, that is one thing which we are using. And another thing is GCD of r with mn is 1 if and only if GCD of r with m is 1 and also GCD of r with n is also 1. Okay, so if r with m, how many numbers GCD is 1? There are 5m such integers. Okay, and then so each of these 5m columns, there are their GCD with m is also 1, but what happens? they consist of n rows, and since Q is going from 0, 1, 2, 3 up to n minus 1, we have phi n elements that are relatively prime to n, and so there will be phi m into phi n numbers which are relatively prime to mn. So this is a proof of the theorem. So we have application to this. Okay, what is that? See, suppose any number, any integer. Now you have to pay attention. Okay, any integer n. What you do is you write it as product of powers of primes. Any integer, you are writing it as product of powers of primes. Okay, suppose 100 you will write as what? 2 into 5 square means 2 square into 5 square. Okay, you will write 2 square into 5 square. So how to find out this phi of n? So phi of n, I'm writing phi of, so I'm writing the prime factorization. Okay, phi of p1 raised to k1. So prime power factorization of any number can be written by fundamental theorem of arithmetic. I can write. Now, if their GCD is 1, if the GCD of these two numbers is 1, then phi of what n will be phi of this into phi by the result which we did just now. Okay, into phi of this, and phi of p1 raised to k1 will be what? P1 raised to k1 minus p1 raised to k1 minus 1. So this is the formula. So given any number, I can write the prime factorization of n, and then I use this theorem to get that phi of mn is phi of m into phi of n. Okay, phi of m into phi of n, and phi of p1 raised to k1 is this. Phi of pr raised to kr is this. Now let us look at this. Okay, this can also be written in this form. Okay, so I see, for example, 100 you are writing 2 square into 5 square. 2 square into 5 square. So what will be phi of 100? It will be phi of 2 square into phi of 5 square. What is phi of 2 square? Will be 2 square minus 2. 2 square minus 2 is 2. Then what is phi of 5 square? It is 5 square minus 5. 5 square minus 5. 5 square minus 5 is how much? 5 square is 25. 25 minus 5 is 20. 20 into 2. 22 into 2 is 40. So phi of what is that? 100 will be 40. Have you understood? So now, so this helps me in finding phi of any number. Okay. Now some more simplification we can do. See, if I take p1 raised to k1 common here, okay, from each of this, then what will happen? There will remain 1 minus 1 by p1. Okay, I'm taking p1 raised to k1 common here. So this is nothing but n. So our formula I can write as phi of n is n into 1 minus p1 up to 1 minus 1 by pr. Okay. Next is, so this is one formula. So phi of n is n into 1 minus product of all whatever primes we have here. 1 minus 1 by p1 up to 1 minus 1 by pr. This is one formula. Another formula is you take this common, p1 raised to k1 minus 1. Or you use this formula. This formula can be used, this or this. So if I take p1 raised to k1 minus 1, then what happens? P1 raised to k1 minus 1 if I take common. So there will be, what will remain here? 1 p1 will be there. 1 p1 and here minus 1. So p1 minus 1, or see when you take LCM here. So p1 minus 1 into p2 minus 1 up to pr minus 1, and denominator p1, p2, pr is there. 1 will get cancelled with this, and so here you're getting the power this p1 raised to k1 minus 1, so on. Okay, so these are the formulas. Okay, so here one more you can write. This is n into 1 minus 1 by p1 up to 1 minus 1 by p. Or this formula you can use, or you can use this, or you can use this, or when you do the numbers directly you can do. Okay, so if I ask you to find what is phi of 105, phi of 42, phi of 100, phi of 96, all you can do. Let us do this now. Okay, so now the first sum is calculate this. Okay, so any big numbers also you can do. Now 36,000 is done first. Okay, so 1000 I write 10 cube, then I write 3 square into 4. Okay, see, you can do like this, or you can do by another method. See which formula you want to use. You can actually, this formula will help you very quickly, I think. See, this is n. Whatever number is the n into 1 minus 1 by p1. These are the primes which are there here. Okay, so suppose 3, 6. So though this is done in different way, so I can write 3. It is done in backside also. So this number into, okay, we'll just see that and then we'll come to it. It's done later. See here. Okay, so this can be taken as the formula also. Okay, what is that? Phi of 36,000. Okay, so this will be phi of this is n into 1 minus 1 by p1 into 1 minus 1 by p. Now, what are the primes here? So this number n I'm writing, and 1 minus, so the primes used are 2 is there, 3 is there, then 5 is there. Am I right? So what are the primes here? 2, 5, 3. Okay. Any other prime is there? No. So this, see, this will be 3600 into, you take LCM then. Okay. So 2, 1, 2, 3, 5, 5 will get cancelled here. And here you get 2 minus 1, LCM 3 minus 1, 5 minus 1. Okay. So you get 9600. Now let us see how we have done here. So in different ways you can do. Okay. How did we do here? So see, it is written as 10 cube 3 square into 4. I just factorized it. Okay, so 2 raised to 5 into 3 square into 5 cube. So this, now what I observe is all of these are mutually relatively prime. So this will be phi of this into phi of this into phi of this. Okay, now phi of 2 raised to 5. What is phi of 2 raised to 5? Is 2 raised to 5 minus 2 raised to 4. Okay. What is phi of 3 square? It's 3 square minus 3. Phi of 5 cube is what? 5 cube minus 5 square. Okay. Now this is 2 raised to 5 minus 32. 32 minus 16. So 16. Okay. This is 9 minus 3, 6. So this is 125 minus 25. Okay. So what do you get? 125 minus 25. So 100. So this is your answer. So in different ways you can solve the sum. Understood the method? Now for example, phi of 1001. Okay. Now 1001, is it prime? It's not prime. Okay, so 7 into this, 7 and 143 is the factor. Then you write this as 7 into 11 into 13. Okay, next is phi of 7. What is phi of 7? Phi of 7 is, so here we are using that property. Okay, it's called the multiplicative property. So phi of m into n is phi of m into phi of n. So you can repeat, if you have more numbers also you can do. Okay, so but they should be mutually, they should be relatively prime. They should have no common factors. Then only we can apply this. Okay, otherwise powers we have to take. Right, as power, for this sum we took powers, na? All powers together. They are also relatively prime. And so we can apply like this. Or you can use the formula also. Okay, this is, we are doing the sum with a formula. Phi of 7 is 6, phi of 11 is 10, phi of 13 is 12. Okay, so you get this. Okay, next is phi of 5040. Okay, so this is 504 into 10. Now we are factorizing this. Okay, so what do you get? 2 cube into 126 into 5. So this will be 2 raised to 4 into, okay, so these are the prime powers of primes. 63 is written as 7 into 9. So see, these are the, so if I don't, see, if you use the formula, you can just use 5040 into 1 minus 1 by 2, so on. If you know what are the primes used. Here you should know the powers. So actually that formula will be more useful. No need of writing this always. So you can go by the formula. Phi of n is 50 n into 1 minus 1 by p1. 1 by 1 minus p1 you can take 2. Another prime you know is 5. Another prime used here is 3. Another prime used here is 7. Okay, so like this, you can verify also both the methods you do, answer will be same, 1152. Okay, so this is the technique we have here. Another one, see here, phi of 400. See how to find phi of 400. See, you no need of writing the prime factorization. Okay, n is, I can use phi of 400 is n into 1 minus. So what are the primes here used here that you have to write? So 1 minus 1 by 2, 1 minus 1 by 5. Only 2 and 5 are the primes which are there here. And so you'll simplify this. That will be your answer. So I think this formula will be easier for you. Okay. Because we don't need not know the powers here. Okay. So I can write n into 1 minus p1 by p1, 1 minus 1 by p2. Now for this also 36000. Okay, you write the number, use this formula. So 36,000 into 1 minus 1 by 2, 1 minus 1 by 3, 1 minus 1 by 5. Okay, 2. So what are the primes which are there here? What are the primes which are here? 2 is there, 3 is there, 2 is there, 3 is there, 5 is there. And so this formula can be used. Okay. So have you understood this? 2 minus 1, 3 minus 1. Okay, 5 minus 1. 1, 2, 3, 5 will get cancelled from here. And you're getting this as the phi of this. Okay. This we had done earlier. Another one I wanted to give you. This we had seen earlier. Some more small results are there that we will do. Before that, which are easy with numbers, with numbers that I'll explain. Phi of p factorial. This is not much. This only p is some prime. P factorial means 7 factorial. See here for 7 factorial it is done. So 7 factorial, I'm writing 7 into 6 into 5 into 4 into 3 into 2. Then you're looking at powers of 2 I took together, then 3 square, 3 I've taken 5, 7, then I was applied this. Okay. Phi of 2 raised to 4 is 2 raised to 4 minus 2 cube. Phi of 3 square is 3 square minus 3. Phi of 5 is 4. Phi of 7 is 6. So multiply all this, you are getting the answer. Okay. That is not a big example. Any prime, any number you are able to find phi of that. Okay. Now, something interesting we'll just do. With numbers, first let us do. Okay. We'll come to that. 2 raised to n type, will come to that later. Just this. Okay. Verify that. Phi of, see, there are 3 consecutive numbers. Some interesting problem here. 5186. Okay. 5187 and 5188. 3 consecutive numbers which are having the same phi. Okay. Its value is same. So let us just observe what it is. So 5186. 5186 is phi of what? Phi of 2 into, I take 2 common here. Okay. 2 into, what is that? 2 into 5 into, okay, 2593. Okay. Next is this prime 2593? Is it prime? Yes, this is prime. You have to verify whether it is prime. So this is phi of 2 into phi of this. Okay, phi of 2 is what value? Phi of 2, 1. Okay, and phi of 2593 is phi 2592. Okay, so 2592 is the answer for this. Because we know that 2593 is prime. Okay, now look at this 5187. 5187. Okay, it will be 3 into 7 into 13 into 19. Okay, I can split this into product of primes. And then phi of 3 is 2. Phi of 7 is 6. Because 7 is prime. Phi of 13 is 12. Phi of 19 is 18 because 19 is prime. And again here you are getting the values 2592. Okay. Next is 5188. 5188 will be phi of 2 into 2 into 1297. 1297 is prime. Okay. So you are getting phi of 2 square, phi of this. Phi of 2 square is 2 square minus 2. Okay. So 1296. This is prime. 1297 is prime. So here also 2592 we are getting. So all these 3 numbers have this. Okay. Same phi of n is there. Okay. Now one more sum we are going to do where if our number n is of the form 2 raised to k, then phi of n is n by 2. Okay. And vice versa. So if phi of n is n by 2, then n is of the form 2 raised to k. That is what we are going to do. So some sums based on that. Okay. So in the sums proof without the numbers, you feel it is difficult, na? But actually writing proofs helps us. Okay. So this part I'll explain. Let us see some numbers also now. Okay, twin primes, you're interested? Let us look at twin primes. What are twin primes? They are primes and they differ by, if I say derive a formula for phi of PQ, where P and Q are twin primes. Okay, so twin primes, they differ by 2 and the GCD is also 1. Okay, GCD is 1 and they are primes also and they differ by 2. So what will be phi of PQ? What is phi of PQ? It is equal to phi of P into phi of Q. Okay, so what is phi of P? What is phi of P? It is P minus 1. Okay, what is phi of Q? Is Q minus 1. So see, P and Q, twin primes. We're looking at derive a formula for phi of PQ, where PQ are twin primes. Twin primes means they differ by 2. They are primes. They are primes, so I can use this for, they are relatively prime to each other. And so phi of P into phi of Q. Phi of P will be P minus 1. Phi of Q will be Q minus 1. So, but they differ by 2. So I can substitute here P plus 2. So P plus 2 minus 1. Okay. So P plus 2 minus 1 is P minus 1. Yeah. So I get P square minus 1. Okay, so this is our formula for twin primes. So if you know two numbers are twin primes, okay, then you can use this formula. So phi of PQ is P square minus 1. Okay, where Q and P are twin primes. So understood this now? This is P square. Suppose you know, I think one number earlier we had done 1949 and 1951. Na? 1949 is and 1951 they are primes and they're twin primes. So 1949 into 1951 will be, answer will be, phi of that will be 1949 square minus 1. The smaller prime you have to write. Okay. Okay. Here look at this. Find the twin primes PQ if phi of PQ is 121, okay, or phi of P into Q is 288, P into Q, okay. Now phi of PQ, P square minus 1, answer is we derived here, na? It's P square minus 1, smaller prime. P square minus 1 is equal to 120. So P square will be what? P square will be 121, okay, 120 plus 1. So P will be 11. P will be 11. So if P is 11, the next twin prime it is. So there is a difference of 2. So the next prime is 13. Okay, 11 and 13. Same way we can do for 288. 288. So P square minus 1 is equal to 288. So this is P square is equal to 289. 288 plus 1. So 289. So this is 17 square. So this is, so P is 17, Q is 19. Okay. So these are the sums for, here also one more sum is asked here. If they have twin primes with P less than, you show that phi of Q is phi of P plus 2. So this is simple here. Phi of P, sorry, here it should be what? What is phi of P here? It's P minus 1. Okay, because P is prime. Phi of P is P minus 1. Phi of Q is Q minus 1. Sorry, Q minus 1. Then Q is actually P plus 2. Q is P plus 2. That is, you have to make a correction in all of this. Okay? This is P minus 1. This is Q minus 1. And then P you have to substitute as, Q you have to substitute as P plus 2 minus 1. But you will get end result, you are going to get this. Okay, so there is a correction here. Okay, phi of P is P minus 1. Phi of Q is Q minus 1. And then you substitute for Q. Q is P plus 2 minus 1 you will get here. And then you are getting this answer. It's phi of P plus 2. Okay. Some more results are there here. Okay, small results. See, if n is odd, then show that phi of 2n is 2n. N is odd, 2 is even. So GCD of 2 and n is 1. Okay, so I can again apply phi of 2 into phi of n because n is odd and 2 is even. I can apply that, and phi of 2 is 1. So I'm getting phi of 2n is phi of n when n is odd. But if n is even, what happens? When n is even, it doesn't come like this. It comes as 2 into this. Okay, how you can prove? See, this is even, this is also even. Even means even number I can write as what? Even number I can write as 2 raised to k into m. All powers of 2 you take, 2 raised to k into m. Okay, where m is odd. So this number n I'm writing as 2 raised to k into m. And so this 2 is already there. And so you will get power 2 raised to k plus 1 into m. Now GCD of mn, this is 1. So phi of 2n will be phi of 2 raised to k plus 1 into m. Now phi of 2 raised to k plus 1. is actually, it's done earlier. So this is phi of 2 raised to k plus 1 by divided by 2, or phi of 2 raised to k plus 1, you can find it as 2 raised to k plus 1 minus 2 raised to k. Okay, which comes out to be this. So this is 2 raised to k into phi of m. Now phi of n, what is phi of n? N is this number. Okay, so again this is 2 raised to k minus 2 raised to k minus 1. So here again you will get 2 raised to k minus 1 into phi of m. And so when I compare with this phi of 2n and this phi n, what I'm getting, what we are getting, so we are getting 2 times phi of n. Okay. So these proofs how to write it down, that all you should know now. Okay, because we are starting offline. So go through the notes, and this part I'll explain once again. It's there here in this. So phi of 2 raised to k is actually phi 2 raised to k minus 1. Okay, that is done here. See here. Okay, see, when our number is 2 raised to k, then phi of n is n by 2. How you prove? So it's simple only here. N is 2 raised to k. So phi of 2 raised to k, okay, will be equal to 2 raised to k minus 2 raised to k minus 1. Okay, now you take 2 raised to k minus 1 common. So what do you get? You get 2 here, 2 minus 1. 2 minus 1 is 1. So that factor goes. Okay, you get only this 2 raised to k minus 1. Now, if your number is 2 raised to k, you are getting here 2 raised to k minus 1. That means it is 2 raised to k divided by 2. That is n by 2. So whenever our number is like this, which number? 2 raised to 5. What will be phi of 2 raised to 5? It will be 2 raised to 5 divided by 2. Okay, so it will be 2 raised to 4, 2 raised to 16. What is phi of 2 cube? See, what is phi of 2 cube? Means 1, you have to divide by 2. 2 cube means 8 divided by 2. 4. So if somebody asks you phi of 2 raised to, any number you can find, 2 raised to 7. So what will be phi of 2 raised to 7? 2 raised to 7 divided by 2 means it is 2 raised to 6. So every time it will be n by 2. Okay, phi of n will be, and the converse is also true. If it is phi of n is half of the number divided by 2, then your number will be of this form, 2 raised to k. Okay, so that is proved in the last. The converse part means if phi of n is n by 2, can we say n is of this form, 2 raised to k? Okay, so that is proved. That much we will do today. Okay, one sum here, just look at this. If can phi of n be 2n? What is your answer for any integer? If yes, find an integer. Answer is no. See, why phi of n cannot be 2n? Here we got n by 2, but we will not get 2n because it is counting the numbers. See, it is phi n is the number of numbers from 1 to n, which are relatively prime. But so phi n cannot be 2n because we are counting the numbers from 1 to n only. And so it cannot be 2n. So that is done. So phi of n can never be 2n. That's clear because we are counting the numbers from 1 to n. So it cannot be 2n. So that converse part of that theorem we'll just do and we will wind up for today. Okay. Converse, we have done this part. Okay. I said I'll explain to you this now. Again, see here, this part was done. This part was done. No? See, phi of 2 cube is 2 cube divided by 2. Okay. 2 cube divided by 2. So it is 2 square. Phi of 2 raised to 5 is 2 raised to 5 divided by 2. So you get 2 raised to 4. So these all answers you can write directly. Okay. Yeah, only this part we'll do and we'll complete for today. Okay. If phi of n is n by 2, then show that n is 2 raised to k. Okay, k greater than or equal to 1. So phi of n is n by 2 is this is given. Okay. So let n be 2 raised to k into m, where 2 raised to k, m is odd. The GCD of 2 raised to k and m is 1. Okay, we are writing all powers of 2 will take together, and whatever remains is m, where m is odd. Okay, odd number. So what will be phi of n? It is 2 phi of 2 raised to k into m. Okay, so phi of 2 raised to k. What is phi of 2 raised to k? Phi of 2 raised to k into phi of m, because the GCD is 1. This is all powers of 2 I take here, and whatever remains is this number from this n. Okay, powers of 2 I write here, and all remaining numbers here. So this is phi of m. Okay, we don't know what is m, so we are keeping it as it is. But phi of n is n by 2 is given. Okay, so phi of n is n by 2, so it is this equal to this. So now this is equal to this. I can compare. Okay, so when I compare, what I get, phi of m is m I get. That means m is 1, because for only m is 1 or m is 2, phi of m will be 1. Phi of 2 is 1, phi of 1 is 1, but m cannot be 2. Why? Because m is odd here. Okay, m is odd. So m is 1. So we are getting the number is of the form 2 raised to k. Okay, m is 1 we are getting. So we have proved our number n is 2 raised to k. I'll send you the notes for today, and then this part we will do when we meet offline. Okay, and then this part, this theorem we'll do next time. And whatever we have done, just go through them, write the notes, and if you have any difficulty, you can ask next time. Okay, we'll stop for today. Hope you have understood it. Okay.
ഇത്ര നാളില്ല